Okay, so I had number 11, and number 11 states an equilateral triangle is inscribed in a circle of radius 3 with one vertex at the bottom of the circle. Compute the area that lies inside the circle and above the triangle. So when you draw this picture, you can see this is what you get, and what you're trying to find is the area of this shaded portion. So the first thing we have to do is find the area of the circle, which is pi times the radius square. And we already know that the radius is 3. So we can just plug in those numbers to get pi 3 squared. So we get the area of the circle is 9 pi. Now we have to find the area of the triangle, which is 1/2 the base times the height. Now, unfortunately, we do not know the base nor the height of this triangle because it's not given. However, we know that the radius of a circle is the length of a line from any point on the outside of this circle to the center. So we can divide the triangle into 3 separate triangles, like this. So I'll do the same thing over here to get a better visual. And so we know, since this is an equilateral triangle, each of these angles is congruent in 60 degrees because all the angles in a triangle add up to 180, and 180 divided by 3 is 60. And we also know that all of these sides are congruent. So in order to find the area of this triangle, we have to find this and this right here. Now, since we know that the radius is any point from the outside of the circle to the middle, we know that this part is 3. So what we have to find is this remaining portion. Now we can do this by using trig, because you can divide this triangle here in half to make 2 right triangles, and we know that the radius bisects the angles here, so this is 30 and this is 30. So what we can do is just use simple trig. So we have to find this and then this section and then multiply it by 2 to get the base. So I will call this x and this y. So in order to find x, we also know that this hypotenuse is 3 because that's the radius. So we need to use a function that will find this x while using the hypotenuse, and for that we're going to use the sine of 30, because the sine of 30 degrees is opposite over adjacent, which is x over 3. And we know that the sine of 30 degrees is 1/2, so we get 1/2 equals x over 3, and you multiply each side by 3 to get x equals 3/2. So we know the height is 3 plus 3/2, and we can simplify that by making this 6 over 2 plus 3 over 2. So we know the height is 9/2. So we know what our x is, and now we need to find our y. And we need to do that by using a function that involves both the hypotenuse and the adjacent side, which is cosine. So we can do the cosine of 30 degrees equals y over 3. And we know the cosine of 30 degrees is root 3 over 2. So we get y over 3. Multiply each side by 3, and we get y equals 3 root 3 over 2. And now, in order to find this base, we just simply multiply it by 2. So we can get the base equals 3 root 3 over 2 times 2. And these 2's will cancel out. So we get the base is 3 root 3. Okay, so to find the area of the triangle, we can simply plug in our base and our height. To get the area of the triangle equals 1/2 times the base, which is 3 root 3, times the height, which is 9/2. When we simplify this, we get the area of the triangle equals 27 root 3 over 4. Now, what we have to do is we have to subtract the area of the circle from the area of the triangle. However, if we were to do that, it would give us the area of all three of these sectors. And what we want to do is only find one. So, when we subtract these, all we're going to do is multiply it by 1/3. So, your final answer will be the area of this section right here is 9/2 minus 27 root 3 over 4 times 1/3.